cutters in Cimatron 15. This short video will explain how to define the turning cutters. Turning cutters are different from the milling cutters. They are not rotating. They can cut only in one direction. We have different insert shapes of different sizes, and we have different holder shapes and sizes. This requires different attention and definition. We have separate definition for turning cutters. Clicking this icon will open the turning cutters dialog, which is familiar in look but has different parameters from those of the milling cutters. On the lower left of this dialog, where we are used to set the milling cutters, we have only some information about the chosen turning cutter. The definition is not done here. Starting a new cutter or editing one will open a Gipscam dialog, which is where the definition is actually being done. On the upper left of this dialog, there is a selection of standard inserts that the user can choose from. And on the right side is where the dimensions of the chosen insert are being given. The tip radius, the inscribed diameter, which is seen here, which actually defines the size of the insert, and the thickness. This is where you set the tip direction. It can be left side or right side. There is also an option to define non-standard insert by checking this other checkbox. Once checked, you can put any desired value in the insert sizes parameters. Note that the size parameters will change according to the type or the shape of the chosen insert. On the lower left is where you define the holders. For most of the standard insert, there are some default holders that are ready-made. You just have to select whether it is for an outside cutting, the tool holder, or a boring bar for inside cutting. There is also an option to customize your holders as a solid, profile, or manual setting. To define a solid holder, you should choose the custom option. Once you click the edit button, the custom holder dialog will open. You should select the solid option and click on the select solid to select the predefined holder geometry that you have in your file. Note that regardless of the orientation of the tool on the machine later on, the solid object must be aligned with the x-axis. Once defined, the cutter will be shown in vertical orientation in both cutter dialogs, Cimatron 1 and the Gipscam 1. On the graphic screen, however, it will show as if it is on the machine when the rotation is at 0. The custom holder dialog also has the lead angle parameter. You can use it to set the insert properly in your holder. This is how it looks at 0 degrees, and this is how it looks in 95 degrees, which is exactly as needed in this specific holder. The setting here defines how the angle is being measured. These are the other options, and actually you need to set it as the angle is given in the tool catalog. The definition of profile holders is pretty much the same as with solid. The difference is that this time you should select the profile option and click to select a predefined contour. Note that the contour in this case should be aligned with z-axis, again regardless of the final orientation on the machine itself. In this case, the different cutter dialogs will also show a tool as vertical, and on the graphic screen it will show as it is seen on the actual machine itself with rotation at 0. Another important parameter is the insert facing direction. The insert face up checkbox, when it is checked, the insert is facing up on the top side of the holder, and if unchecked, it faces down and it is hidden behind the holder itself. Subposition. This is another important parameter. There is a checkbox subposition, which only shows if the machine is defined to support subposition in the machine builder. What is subposition? Let's suppose that my tool is set in this orientation with subposition at 0. In order to be able to machine this side of the contour, I have to use it as if it is rotated by 180 degrees around its axis. This is called subpositioning. I can either preset it here in the tool dialog. In any case, there is an option to override this value in each procedure by itself. Imagine this tool with this insert orientation, and the setting is with setup B equal 0. In order to be able to set the tool on the machine, you need to touch the face of the stalk and the diameter. With this orientation, you can touch the face, but you cannot touch the diameter accurate enough. This means that the tool needs to be set in a different angle. By setting 45 degrees in the cutter dialog, the tool is rotated or can be considered as rotated while setting up in this orientation. You can touch both face and diameter properly. System needs to have this information in order to be able to translate the setup to a vertical orientation of 0 degrees. Tool and holder offsets. There are all sorts of holders available, as you see in the image. They differ by type, by size, by assembly, for example, and here, and by tip direction. All of them, with all the variations, they have different spindle to tooltip distances. There are a few ways to define these distances. The first option is when the exact touch of distances are known after the tool is being set up on the machine. When you click this, you have the tool setup data dialog open. You choose the option to specify tool offset, and what you type in is the distance from the tooltip to the spindle face. Still in this option, it depends on the setup B angle. If the setup B is different from 0, then the distances from the tooltip to the spindle face are different, and different numbers are required to be typed in the dialog. Option number 2 is when the assembly dimensions are known. In this option, we choose the option to calculate tool offset and put in the values. Notice that the values are not XYZ, but HVD. H stands for X, V stands for Y, and D stands for Z. Again, you put in the distance from the tooltip to the spindle face. This option, the H sign, depends on the insert tip direction, whether it's left or right-handed holder, and the value of H may flip sign. In this case, it is a tooltip points to the right, and the value is positive, although here in the drawing, in the sketch, it shows as negative. If the insert would be to the other side, then you should put in a negative value. Option 3, again, we go for the calculate tool offset, and this time we put zeros on all fields. In the custom holder dialog, when you choose the solid, we set the dimensions as ATC holder, and we type in the values in the tool offset, same values that we used before. The gauge tip radius is simply put in the insert tip radius value. With all these options, eventually all the tools or holders are properly placed on the spindle face. Thank you for watching.